So we're still on the first booklet of Chemistry Year 10, Chemical Substances, Reactions and Essential Resources. We're looking at mixtures and separating mixtures. Now mixtures can be separated easily. If you look at a mixture there of jelly beans, you can separate the orange, green, red, yellow easily just by hand. In a mixture, the components, what they're made up of, do not change the properties of them. So they look the same, they behave the same. Think of a mixture that you can see different parts in it. So if you're looking at oil and water on the first diagram, you can see oil and vinegar. You can see the vinegar being dropped into the oil. They don't mix, but they're a sort of mixture. When you've dropped them in together, you can see that they're immiscible liquids that don't mix up properly, but it's still a mixture because you've got the vinegar in the oil. The next one is the sand and water. You've got sand at the bottom there, you've got water at the top. They're mixed together as well. Iron and sulphur, iron filings, and sulphur is a non-metal powder. And if you bring a magnet to it, look, the iron filings will stick to the magnet. But you can see the iron filings in the sulphur, in the mixtures. Now these are mixtures that you cannot see the different parts to. These are called solutions. So they tend to be dissolved in a liquid. Usually it's water. So we've got salt going into water, we've got the sea, we've got squash, we've got milk, we've got tea and coffee. So they are solutions. Less easy to see the different parts in it, but they're still mixtures. First way you can separate a mixture, if you've got a solid in a liquid, so something like sand and water, you can decant it. You can leave it stand. The sand will sink to the bottom, or the mud will sink to the bottom in muddy water, and you pour out the liquid. The solid will stay behind in the first beaker. Sieving, you've got big pieces, you've got small pieces in the mixture. A sieve, like a colander, will have holes in it. Give it a shake, the small bits will fall through and the big bits will stay on the top. Now in science we don't use sieves, we use a process called filtration, which uses filter paper in a filter funnel. And this separates larger particles from smaller particles, or it separates water, the liquid particles, from solid particles which are much, much bigger. So it will separate an insoluble solid from a liquid. Face masks are a type of filter. They will stop large particles from entering or leaving it. Magnetic separation uses a magnet to pick up all the magnetic parts in a mixture. So if you've got a mixture and one of those components is magnetic, you can use a magnet. It's often used in recycling plants, so you can pick up the iron and steel and separate it from other metals. Not all metals are magnetic. Or if you've got an ore, which is a rock that contains a metal, you can put it through a magnetic roller and it will get the metal out of the powdered ore. Evaporation and crystallization, when you need to separate a solute from a solvent, in other words a solid from a liquid, evaporation can be used. Heating up the liquid causes it to evaporate and the solute is left behind. So a process for this would be seawater being evaporated. In these big vats here, as long as you've got a hot country, you can evaporate the seawater and you're left with salt crystals. We would use something like this in the lab. And the salt would be still left on the evaporating dish once you'd evaporated the water. Distillation, a bit more complicated. Now if I've got salt water in here, but I want to keep the water, I don't want to leave it to evaporate, you'd use distillation. Because it lets us keep the solvent, which is the liquid, as well as the solute, which stays in here. So the salt will stay here and the water will come out here. So how does that work? Imagine you've got seawater in here with anti-bumping granules. Anti-bumping granules cut down on the size of the bubbles, so it stops the flask from rocking back and forth. So seawater in there. Water starts to heat up, starts to boil, comes up to the top here, and then flows down this condenser, Liebig condenser. Don't worry if you can't remember Liebig, just remember condenser. And these arrows here are showing you where cold water will be travelling. Only around the tube block, not in the tube. And as the steam and the water vapour comes through here, it cools down, it condenses into water. So the salt stays here, the water comes here. Whatever comes over in distillation is called the distillate. And in this case, it would be distilled water. Fractional distillation separates mixtures of different liquids with different boiling points. So what you've got here, you've got a green solution. It's made up of a blue liquid and a yellow liquid. The blue liquid boils at 80, the yellow liquid boils at 100. So when you heat it, which one will boil first? The blue liquid. And the blue liquid will come through first. And until all of that is separated off, then the yellow liquid will boil. Okay, fractional distillation, so a mixture of different liquids with different boiling points. More than two normally. Chromatography is used to separate coloured chemical mixtures. So what you've got here, it's usually water at the bottom. You've got something called chromatography paper, which looks very, very similar to filter paper, but it's in long strips that you can cut into rectangles. And what you do is you put your coloured substances on the bottom here, above the liquid, not in the liquid because they would just dissolve away and wash away. And then as the liquid moves up the paper, the liquid is called the solvent. It moves up the paper, it separates the colours that are in the mixtures. So say I had 3 dots down the bottom here, they've all separated into their 3 colours. Like you just look above them. So this dot that was here would contain red, purple, blue and yellow. This dot that was here would contain red, purple and green. And this dot that was here contains blue, green and yellow. The solvent front is how far the liquid travels up the paper. And the more it's travelled, the more soluble that substance is. We've got a different example here. Whatever you end up with, the pattern on the paper is called a chromatogram. So a paper is dipped in solvent and it moves up the paper, dissolving the colours and dragging them along. The different colours dissolve better than others in a solvent and will travel further up the paper. So this colour, yellow, is more soluble than blue because it's travelled further.